In this lesson, we're going to go over solving linear equations. Specifically, we'll understand an equation, we'll learn to solve for the unknown x in a linear equation, and we'll learn how to check your answer so that you always get it right. So equations have an equal sign. So what this equal sign means is that whatever's on the left-hand side of the equal sign is equal to whatever's on the right-hand side. So for instance, using maybe a non-math example, 60 seconds is equal to 1 minute. If I say I'm going to go to the store in 1 minute, if you were to say you're going to go to the store in 60 seconds, mathematically it would carry the same meaning. Maybe in terms of words you would use one differently than the other to convey something, but these are equal things. If you talk about the king of pop, you're talking about Michael Jackson, or if you talk about flower in terms of hockey, you're talking about our goalie Marc-Andre Fleury. Okay, so those are some non-math examples. But when we're talking about math and linear equations, whatever's on the right has to be equal to whatever's on the left. When we're solving equations, our goal is to find the value of that variable. Again, it's typically x, but it could be something different that makes the equation true. Meaning whatever value that we plug in that we get, we should end up that the right-hand side is equal to the left-hand side. So without picking up your pencil, find the value of x that makes the equation true. So in this first example, x equals 7, it's just 7, and that's because if I plug 7 in for x, 7 has to equal 7. X or something plus 7 equals 30. What does that something have to be in order for this to be a true statement? X would have to be 23, because 23 plus 7 equals 30, and here we have 30 equals 30. Okay, so the value of x is 23. I plugged that in, simplified the right-hand side and the left-hand side, and got a true statement. Next part C, something minus 6 is equal to 12. Okay, so in this case it would be x equals 18, and that's because 18, which was our x, minus 6 is equal to 12, and 12 is equal to 12. Okay, so intuitively we know in these examples what the value of the variable has to be. And so when it gets more complicated, there's some things we can do. Okay, so solving linear equations. So our goal is to find the value of the variable, that makes the equation true. With linear equations, we want to get rid of any parentheses that are there, combine like terms, get our variables to one side and our numbers to the other, and then find the value of x. And I have check your work in all caps here because there's a way to make sure that you always get these problems right, and that is by checking your work. So we'll keep going with our examples. Solve for x and simplify your answer. So our goal is to get to something that tells us what x is equal to. So in order to do that, we need to get rid of everything around x. And your work here and how you organize your work is going to be important. So in order to get rid of the 6 from the left-hand side, notice how it's a minus 6. I can add 6 to both sides. Okay, and I'm going to write exactly what I have. Negative 6 plus 6, this becomes 0. I didn't do anything with the minus x, so it comes straight down. Bring down your equal sign. Again, right-hand side and left-hand side are really important here. And 10 plus 6 is 16. Okay, so now another way of writing this is negative x is equal to 16. Just kind of a side note here. What I'll see is some of my students draw a line to denote this is the left-hand side, this is the right-hand side, to make sure they know what side of the equation they're working on. Again, my goal is to find the value of x. Right now I know what negative x is equal to, and you can pretend that there's a negative 1 here, and so we divide both by negative 1 in order to get x is equal to negative 16. So now we check our work, and the way we check our work is we take the value of x that we found, and we plug it into the original problem. So we had negative 6 minus, and I found that x was negative 16, equal to, and we're not sure, 10. So you can do this by hand, or you can even take one of your calculators for the class and plug it in. Okay, and I get 10 is equal to 10, which is a true statement, which means that the value of the variable is x equals negative 16. Okay, so don't write 10. That's just what we got to make sure that our answer was right. Plug in the value you get for x. Next, solve for x and simplify your answer. So we need to get rid of everything around x. So we'll add 6 to both sides, and I'm going to draw my line just in case you like to do it that way. So we have 9x, negative 6 plus 6 cancels out. If you're $6 in debt and you pay that back, $6 even, you break even at 0, equals 63. I want to know what 1x is. So another way you could read this is 9 times something is equal to 63. What does that something have to be? It has to be 7. X equals 7. And for the sake of time, I'm just going to set up how we check our answers here. And I'll leave the check to you. Solve for x and simplify your answer. So in this problem here, we have variables and numbers on both sides of the equation. The strategy here is to get our variables together on one side, left or right, your choice, and then our numbers on the other. So what I'm going to do is I'm going to get the x's to the left-hand side and my numbers to the right-hand side, but I'm going to do it one step at a time. Okay, so on the left-hand side, I have a positive 2x. I need to subtract 2x from both sides. Okay, and the reason why that golden rule of algebra that you've heard of whatever you do to one side, you have to do to the other is because of that equal sign. You can't unbalance your equation here. Those two sides, that equality has to be preserved. So whatever you give to one side, you have to give to the other side. Okay, so 7x minus 2x is 5x. I didn't do anything with the 52, and it's really important to keep my equal sign so that I know what I'm trying to make equal. 2x minus 2x, that cancels out, and I have negative 13. Just be really careful here. It's a negative 13, or that minus sign has to stay in front because we didn't change anything. Okay, next, I'm going to get rid of the numbers from the left-hand side, so I subtract 52 from both sides. So I have 5x. Bring down your equal sign, negative 65. Okay, so 5 times what is going to give us negative 65? Or you could divide both sides. And again, you can use your calculator here to get x equals negative 13. And just remember to check your answer. We'll keep going. So in this case, we have some parentheses. So in order to see what I truly have on both sides of the equation, I need to get rid of those parentheses. And the way to do that is by distributing. So on the left-hand side, I'm going to distribute the 2. So 2 times x minus 2 times 1 is equal to 8. And we have a minus sign out in front here. So think of it as like a negative 1 being multiplied. So we're going to do negative 1 times x, negative 1 times 1. Okay, or you can think of this as plus a negative if you want. Now I'm going to simplify everything. So I have 2x minus 2 equals 8 minus x minus 1. On the right, I'm going to combine my like terms. So I'm combining 8 and negative 1 to get 7 minus x. Okay, so now this looks very similar to the last problem that we had. We just had to get rid of some stuff in order to see what was truly there. So I'm going to move my x over to the left-hand side. And when you have x like this, it's really just 1x. So we have 3x minus 2. Bring down the equal sign, 7. Add 2 to both sides. We get 3x equals 9. Another way to ask or to get the right answer here is to say 3 times what is equal to 9, or divide by 3. And x is equal to 3 in this case. Remember to check your answer. Example 6, so when we have fractions, it works in a similar fashion. We just have to deal with the denominator there. So there's a couple of different ways to do this. We still want to isolate x or get x by itself, so we need to move everything else around it. In this case, we can add 9 to both sides to get 5x over 3 is equal to 6 plus 9 is 15. And so I'm going to remember this here. Okay. And the first way to do this problem, we won't check this one. The first way to do this problem is on the left-hand side, we're dividing by 3. So in order to get rid of division, we use multiplication. So you can multiply the left-hand side by 3, and if you multiply the left-hand side by 3, you have to multiply the right-hand side by 3. Multiplication by 3 and division by 3 gives us 1. So essentially this becomes 5x times 1, or just 5x is equal to 45. And then divide both sides by 5. So x equals 9. The second way to do this problem is it starts the same by getting the term with x by itself. But if you like proportions and you like cross multiplication, put 15 over 1 so that it has a denominator as well. And now we have a fraction equal to a fraction where we can cross multiply. So 5x times 1 is equal to 3 times 15. So we have 5x is equal to 45, and we end up at the same place. Okay, and you can check your answer on this one. Just a quick note here, if you're going to check your answer on this, I would recommend just putting it into your calculator as it is. So you could do 5 times 9 divided by 3 minus 9, and you would get 6 equals 6. Okay, so you can also use your calculator to check these as well. We've got a couple more examples. This video might run longer than usual, but I'm going to keep going to get done with our last couple. Solve for x and simplify your answer. Okay, so we've got some parentheses again. So let's distribute and figure out what we're working with. So 9 times x is 9x. 9 times 4 is 36. This is equal to 3 times 3x is 9x. 3 times 4 is 12, and then we have plus 24. So I'm going to combine like terms on both sides. So on the left-hand side, 9x and 36x are not like terms. We have 9x plus 12 plus 24 is 36. Look at what you have. 9x plus 36 equals 9x plus 36. So this is always true. But let's keep going. Let's say we wanted to get x's together and our numbers together. So we would subtract 9x from both sides. 9x minus 9x cancels. So now we have 36 is equal to 36. Is 36 equal to 36? Sure is. So this is a case where, and you'll see this as an option, our answer is all real numbers. So remember at the beginning of class we talked about the real numbers. Those are positive and negative numbers. So any value you plug in, 1, 0, 100, pi, doesn't matter. This equation will be solved. So on the software, this is where you would click all real numbers. Okay, and I'll take a moment to pause. You could get something that says like the solution set is, and that's reserved for when you have an answer. So if that phrasing were there on example 6, your solution set would just be 9. Okay, so we've got, you can have one number, you can have infinitely many solutions. So there's multiple values here that solve the equation. In our last case, you might already know what it is, but let's go ahead and solve. So we have 3x plus 5 is equal to 3x plus 17. Get our x's together. So we have 5 equals 17. Is that true? No. If I had $17, I wouldn't want somebody to say I had $5. So this is not true, nor is it ever going to be true. So this is a case of no solution. Or in the homework, you might see solution set is, and then it gives this. This is the empty set, meaning there's nothing there. Okay, there's no solution. Part of your homework is to solve for variables in terms of other variables. That'll be continued on another video. Thank you for watching. If you have any questions, please feel free to reach out to me.